So I'm Gracia from the High Performance Computing Center in Stuttgart, Germany. And okay, I thought this was a large software stack, but in the meantime, I've seen much larger software stacks here. So let's just talk about the challenges and the issues. The outline for the talk is I want to go a little bit into the background, what HLRS is, how we did deploy software before that, and things like that. Then I will walk you through three surprising moments that we had and how we dealt with that. I have a very short wish list at the end, and then I want to just mention what the current status is and the outlook on using Spack at HLRS. So the High Performance Computing Center Stuttgart is one of 3 German national HPC centers. Traditionally, we have many users from the engineering community, and we also have a number of industrial users on our machine. So we have just installed a new system called Hunter. That's a Cray HPE Cray EX4000. We have an APU partition with AMD MI300A. It's around 200 nodes, so not too big. And we have a CPU partition with AMD Genoa, 250 nodes, I think, around that. The CPU partition is mainly for industrial customers, so the academic customers are supposed to use the APU partition. And the reason for that is that traditionally we have been a CPU-only center. This is, in fact, the first machine that we have that relies for computing mainly on APUs. So our users are not really, they did not really port their codes in the past. So this is kind of a stepping stone system for a larger installation that will follow in 2 years' time. And we really want to encourage our users to port to APUs and use that. So the software stack, so far until recently, we handled the software stack like this. So the distribution, the responsibilities for installing software is actually distributed across a lot of groups in the center. For example, my group does performance analysis tools. There's other departments that install the numerical libraries. There's departments of people that install the ISV codes. So responsibilities are all over the place, and also the method for installation is a little bit all over the place. So for example, I have used a lot an in-house package manager called SIT, software installation tool. There's people that use their own in-house scripts, very sophisticated bash scripts sometimes. There's people that rely on third-party installers. This is mainly for the ISV codes, for example. And there's people that do some kind of magic on the command line that nobody understands and nobody can reproduce and do things. So deployment is a little bit complex and time-consuming. And the reason why I got involved into Spack is because last year in the summer vacation we had an incident where HP installed a security update which broke our, I think it was XP-mem, which broke our MPI, and I tried to fix it. It didn't work. And for 2 days, I was dancing around and trying to bring the cluster up to working fully. Because essentially, I didn't know what was installed, how things were installed. Nobody knew because people were on vacation. So we decided to get rid of that old system. And the ambition for Hunter is, first of all, we want to have fixed software releases. So far, we were like growing our releases organically. Whenever we had new versions or the users wanted new versions, we installed them. Now we want to have fixed releases with fixed versions for a while and then replace them after a couple of months. And then the ambition is to follow the recycle of HPE, Cray CPE, the program environment, which is 2 or 3 releases per year. And our operations team also tells us that they want to update the basic operating system 2 times per year or 3 times. So potentially we're looking at 2 to 4 releases per year. And for that we need an automated deployment of the whole software stack, and we need to be able to parameterize the configuration of the software stack. So we had some experience with Spack before, but not much. So we thought Spack would be a good idea to implement this automated deployment, and everything is really written down in configurations. So that fits our needs. And the typical spec for us would look like we have package foo, we always install with MPI, obviously. At the moment, we have a dependency only Cray MPitch, but since HLRS is traditionally an OpenMPI contributor, we would at least in the near term would like to have OpenMPI in the machine as well, and then we would add a second MPI variant. And at the moment, we're compiling for the Cray compiler, RockMCC, which is the AMD flang, and we have some users that are still asking for GCC. So we support those 3 compilers, and typically we would install one variant for ROCm HIP and a variant for without ROCm HIP. And at that point, I would really be glad if we can make this one variant, because I think ROCm and HIP is essentially the same, and we have 2 names for the variants here. And we have a lot of users for numerical libraries that insist on using int32 indices for their array sizes, and other users want to have int64 for array sizes. So typically we install 2 versions of numerical libraries. At the moment, we have like 50 packages, each of those packages between 3 to 12 instances, so that's around 300 roughly packages that we would install on the machine at the moment. So we have some constraints, operational and administrative. For example, one is that we are asked to reuse OS packages whenever possible, because our system administrators want to have security updates on the machine and then don't trust that we will install them through Spack. Consequence of that is that our packages YAML is very long. I've put it there on the right side, and it goes down at least 7-8 times further. So probably will go down half the building here. Our users are asked to compile with the Cray wrapper, so they would use CC, for example, not MPI CXX. So our software stack must be compatible with that. And we want to have one monolithic software stack as opposed to have separate stacks for different user communities. So they should all have more or less the same view, all users, and not, I don't know, mod tricks to hide software from parts of the users which are not compatible with other parts of the software stack. And our system administrators are very concerned with the size of the software stack, so they ask us to have it as small as possible. That means we're going to install everything that's not performance critical with the core compiler only. Okay, so price, first one. As I said earlier, we prefer core compiler GCC 11.4, and then one of my colleagues say, I want to have SCORP installed. SCORP is a performance analysis tool. It should instrument HIP code, so I add the variant plus HIP, and I want it compiled with Cray and Clang compiler. Another colleague says, I want Scalaska, and Scalaska depends on SCORP, and again, he wants to have CCC and Clang. So both of us would expect that I get an instance of SCORP with HIP, and we install an instance of Scalaska, and that depends on SCORP. So we would both expect that it chooses a dependency, the same variant that we installed above. What actually happens is that I install my root specification with SCORP with HIP, but that is OK. And then Scalaska gets its own dependency, SCORP again, this time without HIP. And compiled with the core compiler. OK, so we don't want that. That is, we expected that if we provide root specifications in our environment, that should take absolute preference. In particular, if we set non-default variants like we did here, so we specify plus HIP with SCORP, and the default is without HIP, and that doesn't help us at all. Workarounds that we tried, or that actually work, is repeat the variant and all the full specification in the dependency. So my colleague should have said Scalaska dependency SCORP plus HIP. That somehow violates the separation of concerns. I mean, in that case, my colleague is myself, so I could have done that. That is very easy. But sometimes actually those specs are provided by different people, and they don't really know that how to configure SCORP, let's say, when he is installing Scalaska.
Did you try
I tried. Yeah, we're aware of that, but sometimes we don't want to propagate it all the way down. But in this situation, it would have helped, for example. Okay, and specifying the configuration of the dependencies in this easy case, it's easy. But if you have a little more involved dependencies, for example, here Patsy is at the bottom, and you want to add all the dependencies with all the variants for all the stuff that is above, that can get a little bit messy to write down. So that's one workaround. The other is we have reverted a specific commit, make strong preferences even stronger. If we revert that in our copy, that solves all the problems that we have seen. I can only guess that the reason for all this problem is that we have here this preferred GCC 11. If we don't put that there, then the concretizer doesn't put additional priority or additional weights on square P with GCC, and then everything works out. But at the moment, the practical solution that we've chosen is to revert this one commit. That works best, but obviously it's not sustainable. We would like to get rid of that. That is not something we would like to have there forever. Okay, so that was the first issue that we encountered. The other one is that we are very picky with our compilers. So we're installing another tool, Xtry, that depends on Cray MPitch. And we want to compile for CC and Clang. So we would expect that one version of Xtry is compiled with the Cray compiler and has a dependency Cray MPitch with the Cray compiler, and the other instance that we're installing is compiled with Clang and should have a dependency on Cray MPitch with Clang. What actually happens is that both of our Xtry installations, which use different compilers, get the same dependency, which is Cray MPitch with Clang. And in some cases, that is not a problem. For us, it is. In particular, since sometimes I've seen, actually, not for this particular case, but actually, the Xtry version would be compiled with CCE and MPitch with Clang, and the other Xtry version with Clang would get MPitch with CCE, so just turn around. So that is like an arbitrary random assignment of the dependencies when they're the same weights. I don't know. That is actually a huge issue for us, because traditionally we had the policy that build the applications, the libraries with the same compiler that we have compiled MPI with. So we really don't want to have an application compiled with one compiler and using an MPI that was compiled with another thing. We suspect, this is the suspected cause for some of the link issues that we see with our users. We have 2-3 users that have funny link issues when they use our stack. And we know one case at least where it breaks our performance analysis tool because it's using the wrong MPI in the backend, and it's implementing the wrong MPI. Workaround for this is just being more verbose again. Rather than specifying just the compilers, we specify the compilers together with the the MPI dependency, and specify the compiler there as well. This makes the configuration files a little bit, they're not nice to look at, but it's not a big deal at the moment. Okay, and the last thing that I would like to mention is what actually took me longest to realize and was very surprising. And I guess if I had read the website properly, the documentation, or maybe it was a little bit spelled out a little bit clearer, this could have been very easy to fix. So I started with the compiler definition like this. So I want to use the Cray compiler, and then for the path to the Cray compiler, I would just specify capital CC for the C++ compiler. And then I instruct Spack to load modules programmed for Cray and a specific version of the Cray compiler. Our expectation was that Spack would load the module at build time and thereby configure the behavior of CC, and particularly would choose the proper backend compiler. What actually seems to happen, I'm not sure, but that is our interpretation, is that Spack largely ignores the modules. In particular, it doesn't swap really program in the build environment. It just loads the modules to inspect which paths are there to set, I don't know, linker path or things like that, but it doesn't really load the modules. And the consequence is that in all our builds, it was very non-deterministic what compiler was actually used for building things. So that was really surprising. It took us a long time to realize that was happening. And the solution for that is, and it's actually also spelled out very clearly in one of the HP's pages, that you shouldn't use the Cray wrappers, but you should use the, I don't know, the drivers directly. So you specify the full path to Cray CXX, and you don't load any modules. So we're doing that. This creates other kind of problems, but that is, I don't want to go into that at the moment. But that's something maybe that is really worth putting in the documentation a little bit more clearer. Yes. Okay, my wish list. The first thing is I want to have Spack and environment variables everywhere. So the usage of Spack variables or environment variables across the YAML config files is not very consistent. For example, if you're in the module section, you want to specify the root of the lmod modules, then I can use an environment variable, Spack user prefix module files. That works very nicely. But then I want to have a concrete environment include concrete. Using Spack variables here fails, doesn't work. Using environment variables here fails as well. I'm forced to do an absolute path to my concrete environment, which is something we really don't want to have. So any of the other two options would be fine. Then we don't have to change our configuration files in the repo when we switch to another release. But absolute path is really not good. This is actually probably easy to fix. For include concrete, I've done a naive prototype implementation, and there's a pull request for that, which nobody has looked at so far. But this is something that in our Spack repo we have done, and it works since 8 months now without any problems. But again, we look just at one case, not at what other people are using it for. So I'm almost done. And the other one is probably a little bit more complicated, and I have no idea how to do that. So the motivation is that some packages allow or expect post-install customization. For example, OpenMPI, there's a file where you can configure the MCA parameters, default values for MCA parameters. Not all sites change those, but sometimes we do customization there. I don't know, setting eager limits and things like that. So that's something that we know. We know our network, so we know what to write there, and we would like to do that. And it's tedious to do this after the installation by hand. Or sometimes we want to, let's say, monkey patch packages, change packages. For example, again, this Scorpy. Scorpy sometimes forgets to install wrappers for HPC. So we would like to call the command Scorpy create a wrapper for HPC after installation. So we would like to have like a post-install step, and ideally in a way that would allow users to extend existing packages without touching the package pie. So we would like to have some kind of mechanism to splice a post-install step into an existing recipe that is not in our own repository. I mean, this can be done with, there's a, I don't know, a Python after installer thing like that. So if I control the package, I can do that.
You can inherit from built-in and do this.
Yeah, okay. Yeah, if as I said, if I control if I own the package or if I have it in my repository, but ideally I would like to have only the post install in my repository. It's like,
yeah, you only have to do just.
Yes, we are right. Yeah, okay. Yeah, let me think about that. Okay.
Same thing I showed him.
Okay, cool. Thanks for that. So let's forget this slide. It's solved. But maybe, yeah. Okay, so coming to the end, the current status and the outlook. So we have deployed our first our first software stack official one mid-April. We don't have all the packages there yet that we would like to have, but rather than waiting another couple of weeks, we thought, let's give it to our users. There have been surprisingly little complaints so far, so it's working good, apart from a few things that we knew that would fail or would potentially cause problems. And this has been largely automated, fully automated, at least the Spack part. There's still a part of the stack that we built without Spack, but this part is fully automated, and that works really great. It takes, like, I don't know, 6 hours to deploy the software stack, but then it's done. One very good thing for us is that the software stack is now fully described in config files in our Git repos. That helps with reproducibility, with auditing. So we have to go through a certification process for data center security, and they are asking us to be able to tell at each time what configuration of the software is running. So that is a very important thing there. It helps for debugging. It helps for user support. We often get the tickets, my code doesn't work. It used to work until recently, 2 weeks ago. We can check. Nothing has changed in the last 2 weeks, and now we can be fairly confident that it's up to the user that he changed something, not our system. And before that, we could not really be confident in that it was actually the user that changed things, not us. We have provided a Spack user module that allows our users to use Spack with the full site configuration, so including all externals, including all compilers, including all the packages that they can install their own software with. The next step is to extend our software with more packages to bring it up to the full size. And one thing that we're really looking forward is the separation of the Spack repo, the package repo from the Spack core, so that would help us a lot. We can pull in more recent versions of the packages much quicker because we always we want to use Spack core, not development, but only releases. And since the release cycle, it's unpredictable to us when the next release will come. So having the separation here is very good. And Hunter is not only our only cluster. We are considering to use Spack for all our clusters in the future. So thanks a lot for your attention.
Okay, thank you so much for some questions.
We merged your PR.
Congratulations.
Okay, thanks.
All you have to do is give a talk to Spack.
Yeah, that's what I came.
On 17, when you were talking about the MCA parameters, for the most part, with OpenMPI, for the most part, our MCA parameters we can handle through the corresponding environment variables, which we define in the modules.yaml specification. I agree. That is a little bit constructed case. We don't use it for that because we don't have OpenMPI on the machine. But it was the simplest thing that I could find to present here. But I don't remember that we changed this in the configuration. So in most cases, it would go through environment variables and do this in the module file as well. Yeah, right. But you know, is everything you need from MCA parameters, is it exposed by OpenMPI through an environment variable?
I didn't understand that. Sorry.
So the MCA parameters in the .conf file, you can generally set them through an environment variable?
Yeah, that's what we do normally. Yeah.
Okay, gotcha.
Yes.
Okay, great. Thank you.
Okay, Yuki can start setting up maybe, and then we can answer one more question. I don't know. Okay, sorry.
I wanted to know what the reasoning behind using the heavy use of matrices and the multiple tool chains in one environment file. Is there a technical reason you need to do that as opposed to splitting the compilers into multiple environments?
That's something that I've heard that many people do that. We thought it would be easier to have everything in one environment. Again, to avoid duplicating works, having one environment for Cray, environment for Rockham. Yes, I know, yes. That's something we will consider. So if we run into more issues with the concretizer, obviously they're much easier to solve if we separate that out by compiler. So we would look into that. I don't know why we started like that.
It's kind of intended for that, so I mean, I guess like, it does get hard to manage all the constraints at once. And
Yeah.
so it's a scaling thing. I mean, it may be easier to select.
We have different environments for topics. So for example, we have one environment for tools, one for the numerical libraries and things like that. So we decided to split it by responsibility and not so much by compilers.
All right, thank you so much. One more round of applause for Jose.